Finally, let me finish with some thoughts on unsolved problems and potential future work in this direction. And as a quick reminder, we did talk about well-known shortcomings of NMT and the role of beam search in causing these problems, and then moved on to the question, okay, if beam search is causing some of these problems, then does removing beam search or replacing it with a different decoding algorithm improve the situation? And now, as I said, I'm going to close with an outlook of sorts. So going forward, what I can imagine could lead to some progress in the field is, first of all, fixing the problems that MBR currently has, and also I can imagine that it could be useful to shift attention away from MBR again, and so stick with beam search and try to improve the alignment between the training and the decoding objectives. So that's a completely different way in which the field could make some progress. But I'm going to briefly talk about each of those. And so regarding fixing MBR's problems, what are the unsolved issues that need fixing? Two glaring problems that I can see are the efficiency of the algorithm and the idiosyncratic biases that utility functions introduce into MBR. Let's start with efficiency. Let's talk about efficiency first. MBR is not at all an efficient algorithm if you compare it to beam search, and that's for two reasons. One of them is that a large number of samples need to be drawn from a model, and the second one is that in order to arrive at a final translation, the utility function needs to be called a large number of times. To illustrate these 2 points, first of all, let's talk about the model samples. So because MBR operates on a pool of samples of size 100, for instance, this means that 100 samples need to be drawn independently from the model. They can be drawn at the same time, but still you need to need to sample 100 times from the model. And then secondly, the number of times that the utility function needs to be called. What I have here is an excerpt from the algorithm I've shown earlier that shows that because you have to compute the utility of each sample Si, this means that you have to call the utility function several times to compute the utility of one sample of only, because you have to compare it to every other sample in the pool. And so obviously the efficiency of MBR has to do with the size of the pool, but pools so if the size of the pool reaches a size that leads to a reasonable translation quality, like 100. So that's as a rule of thumb, I think 100 works well, because if I use in my own experiments, if I used pools with a size of 100, this in general leads to translation quality that is similar to beam search. If you use pools with a size of 100, already the number of samples you have to draw from the model and the number of times that you have to call the utility function is prohibitively high already, and MBR at this point is starting to be an intractable problem again in practice. So that's the efficiency problem that needs to be improved. But luckily there's already some very recent work on this that was very recently published on arXiv, again from Brian Aikema and Wilker Aziz. The main focus of this work is to improve the efficiency of the MBR algorithm. I would like you to really encourage you to go and read this work. And then about idiosyncratic biases of utility functions, what this refers to is the fact that to use MBR, you have to choose a utility function which may introduce some biases that are some particular biases that are specific to the utility function. And we've seen this. I illustrated this with results from length bias experiments, where my point was that if you use a precision-based metric like BLUE, then translations are too short, but if you use a recall-oriented metric like METEOR or character F, then the translations are too long, and this is in general hard to control, and it's an unsolved problem of MBR. Then as the very last point, I think it could be fruitful to invest in aligning the training and decoding objectives. I know that this has been done before, but a very recent work on this is by Rémi Leblanc and colleagues. It's a work called Machine Translation Decoding Beyond Beam Search, which revisits this problem and is basically suggests a number of reinforcement learning algorithms to integrate that decoding objective into the training procedure. Basically, again, I can highly recommend to check out this work. Now, very last slide with a general outlook. In general, I would like to see more emphasis on the role of decoding going forward, and I think it is very desirable to have a general awareness that the decoding algorithm or beam search is a replaceable component of a system, which wasn't always clear to me. And with that, I'm done. Thank you for listening, and I'm looking forward very much to our discussion.